Okay, so it seems that we are live. Yes, we're live. And since this video is going to be on YouTube later, I'm not going to keep anybody waiting. Today we have invited a few developers that have developed very interesting projects around Intel Internet of Things technology, and we wanted to give them the stage to talk about their projects themselves, their inspirational, their challenges, and how they overcame these challenges, and just exchange very honest and very first-hand experience on how they created those projects. My name is Sulamita Garcia. I'm based in Munich, and I'm developer evangelist for Intel for Internet of Things. With me today, I have Maximilian. He's an application engineer,
Hi.
also based in Munich. Say hi.
Hi, this is Max.
And I also have Maud. Maud
Hello.
is our social media and marketing partner from Be My App.
Hi everyone. Hello.
So if you have any follow-up questions, anything that you'd like to talk about, webinars, hangouts, or the Intel technology, then you can send questions to us. Here today we have Ali.
Hi.
Ali. It's also based in Munich. We have Marco. Who is right now based in Tuscany, although he travels a lot. We have Markus.
Hi, everybody.
Also from Munich. And we have Tim joining us just from the Netherlands. Hello. So I'm going to start calling each one of you to talk about your experiences. And I just want to let everybody know that we have a Q&A enabled here. So you can make questions, and we're going to pass these questions to the speakers. So Ali, since we're starting in alphabetic order, can you talk about a little bit about yourself?
Well, I'm studying here at the Technical University, and pretty much like everyone else in this hangout, I like building stuff and having fun with technique.
And so you're a student in the Technical University of Munich.
Yeah.
What do you study exactly?
Informatics.
Informatics. And where did you find out about, I understand your project is using Intel Edison, right?
Yes, using the Edison.
How did you get in contact with the Intel Edison?
I have heard about it from Max, because we are studying together, and we also met in Chaos Computer Club here in Munich. And I got one to play with, and you can do quite a lot with that, so I had spent some time with it.
And how did you got the idea from what you would like to do with that?
Well, it first started with what can I do with that, because I received that basic GRU kit with the LEDs and some sensors and stuff. So I looked what could I do, what's interesting, and the lights are the easiest to get started with. And then I thought, okay, blinking LEDs, not very interesting, what can I do with that? I'm very interested in music, so I decided maybe I could do something like that. And I remembered a trip in Brussels in Christmas in city center. There were very nice lights and music together every hour. The buildings are lit in different colors according to music. And I thought, okay, maybe I could do something like that, but the problem is you have to pre-program everything, and I also wanted to be able to play and have the lighting according to my playing, so I decided to do it in real time, analyzing the audio signal. And this is basically what the project does. The Edison is controlling the lights, and either Edison or another device is playing audio or recording audio and analyzing it. On the Edison, there is a simple Python server running, which gets the request about how bright each channel of RGB lights should be, and the client sends those requests to set the lights. This can also run on localhost, so you can play music on Edison. And as told, you can either play live music, or you can play a recorded file, and it can also set the lights accordingly.
I don't know if we can we see that?
Yeah. Hope everything works well now. I'm trying to plug it in. Let's make room a bit darker. So basically, when we have a bass tone like this, hope you can hear that, it's blue. Then when we have something in the middle, then it's green. I think you can see that very well. And then when it's in high tone, then it's red, like this. And of course, it's more beautiful than music is playing, so I have prepared a short demo for you.
Nice.
Yeah. So this
That was really cool, thank you. And what language or libraries are you using for that?
I'm using on both server and client ends Python. Let me Python. I started with Flask on the server side first because I just wanted to get going, but this was one of the first difficulties I met on Yocto, the distribution that's documented by Intel. On that, I couldn't install Flask because pip didn't work well. I couldn't figure it out, so I had to install UB Linux on my Edison. Didn't work well, but eventually I ended up getting rid of all the dependencies. Now it's a very simple Python code, the server side, running on the sockets library. It's also online on GitHub. I don't know if we can share the link. Maybe we can do it on the YouTube description later.
Or
Yes,
maybe do it on the Google Plus page under the video.
And
on the event page.
Yeah, we can figure it out. And on the client side, I'm also using Python with sockets to communicate, and I'm doing the audio analysis with NumPy, and for recording, I'm using AlphaPy.
I'm curious about. I know very little on Python development. So, are you using the Groove's sound sensor as well?
No, because the Groove sound sensor can only detect how loud it is. But I'm also interested in the frequencies because I have 3 bands and I want to separate them, so I'm using the microphone of my computer. That's why my computer is the client right now. If I wanted to use the Edison as the client, then I would also need a separate microphone.
Oh, okay. Yeah, maybe I don't know. There is any microphone that you can use the USB client port on the Edison?
Oh, well, right now I don't have any, but there definitely are some on the market.
Okay. Oh, that was really cool. Is there any suggestions for people who are getting started, interested in music as well? What would you say for people who would like to go into the path?
Well, just keep playing with stuff, and then sometimes you get a good idea, then you spend a few nights without sleeping, working on it, and it works well at the end.
Okay, thank you.
Playing around.
Yeah, that's the idea. If anyone has any questions, you can submit it on the Q&A. I just wanted to say hello to Constance as well. Hello, Constance. And yeah, do any of our other participants have any questions for Ali?
So you could use, I used already on the Edison webcam over the client USB port. So I'm pretty sure your microphone should also work.
Yeah, it probably would. So I don't have any, and it worked well on my computer. And I also wanted it to work on a separate client because you don't use an Edison daily, like as your smartphone or for your daily computing. But I could just set it up there and install the lights in my room. Then I can listen to my music on my smartphone or on my PC, and the lights would pass to it.
Yeah, cool. Anyone else?
Okay, then if anybody has other questions, we can come back to Ali. Marco Dalpino, good evening.
Hi.
Hi. Can you tell us a little bit about yourself?
Okay. What I am, who I am, and what I do. I'm just a little older than Holly, that preceded me. I'm on the computer and the IoT and development from many years. I approach to the Intel ecosystem with the communities, with the communities activities here in Italy, and I started to participate to some community meetings. And in the last 2 or 3 years, I became first of all an innovator, an Intel innovator, and then a black belt for the IoT and also for real sense. And I do many activities around Italy and also out there. And for my work, essentially, I work in the embedded. I'm a developer, and for the community, I try to evangelize about the technologies. I'm very excited for all the technology, and especially for the IoT. And that's it, I think.
Yeah. For those who don't know, the Intel software program, the innovators program, and the black belts are people who are not Intel employees, but they're very excited about Intel technology, and they're evangelists on our behalf. So Marco, for instance, is a consultant. He has plenty of experience in so many areas around technology. And he is a very curious person. He always enjoys new technologies. So we have a special program for people like him to have access to our technology, to speak on our behalf, and to make cool stuff. And anybody interested, they can talk to us after that. So Markus, like you said, you have been in touch with many of our technologies before. What is it that you are bringing us today?
So today I I bring something that is a mix, because I'm also very involved also with the Microsoft ecosystem, and about that Microsoft developed something about the IoT that is a special version of Windows that is named the Windows IoT Core. That to be I explain just into words. It's a complete version of Windows without the shell, without the window, let me say, the start button whatsoever. But you have all the APIs, all the access to the or what Windows expose for developing, and you can use it also on small boards. There are many boards supported, and obviously there are some that are Intel based. For that reason, I try to use this special version of Windows using a board that is the Mino board Max, that have an Atom CPU, and I try to use it to build a small rover that I have here. So I can show. I don't know if you see it very well. Yeah, hope so. And what I do essentially, I try to get some standard sensor that is usually in the maker ecosystem for Arduino or Edison, whatsoever. I try to build everything together with the board, and using Windows 10 IoT Core, I drive it. What is particular for this specific type of development using Windows, that I can reuse all the development tools that usually in many developer already know for his work for building application, and I can reuse all my knowledge just for making IoT devices like this. And that's essentially the main thing I like from this. So I can show you what you prefer, if you want to see something that working, that going around, or want to know more about the technical part.
Let's see moving around first, and then we talk a little bit about the technical details.
Just a moment, because I have to I have to share my screen also. I try. Why? Sorry. I try to show it. I don't know why it doesn't work now. Because now I have a problem to show it exactly with that, because I have only one webcam here, and I can show you. You see it?
Yep.
Okay. So what's happened now is that the rover actually have a sensor distance here on the front. He'd have a standard webcam that is an USB webcam, a LED, and a motor driver on the back. What actually do? The rover actually go forward if it meets some obstacle. It try to avoid it, going back, rotating, and trying in another direction. Now I have a problem to show it, because I prepare a little video. If I see how to show you it.
On Hangout, what we tested before is that if you show only one application, and you have another application interposing, then you see everything blank. Or either it's easier to share your whole desktop. Just put the video, maximize and share.
Okay, I try. Let me try. Yeah, but I have a problem that the option of sharing my video is disabled. Actually, I don't know why, but it's disabled. I'm inside Chrome, but That's okay. Okay, I found it. Sorry. Hope you are seeing.
Yes.
Yes. Okay. This one is actually the rover that when meet actually, oh sorry, this one is the version controlled by an Xbox, the Xbox controller. We can choose the two option, and actually this this control. Let me disable the screen share. Okay, where is? So when you can choose between the two solutions, we have developed a service on the cloud where I can from where I can control the rover using a small. It's a very simple user interface. The rover connected to this service and the service send it the command directly using a technology that Microsoft developed that is named SignalR. Otherwise, I can directly using the Wi-Fi direct from a PC that connect with the rover, and using the normal Xbox controller, like the guy in the video, I can control directly from a local PC. On the other version, I can not version, but on the other mode, the rover can go around the environment and try to avoid to the obstacles. So. What's more, essentially, one of the main things is for this project is very cheap. The rover itself is very cheap. It doesn't cost at all. And so, tell me.
Yeah, so I can see that this project probably had several points where you had to sit down and think about now how am I gonna do that. Do you remember any specific moment? I don't know, a sensor or some movement that you were trying to do. There was any moment like that?
Oh, so when I start to develop this project with another friend, we're coming from other experience. We are coming from experience like Arduino and other technology inside the IoT, and we work as developer, and we want to in our experience we want to give our experience as a developer and have back what we are using every day inside this type of project. And we see in this solution this possibility. We also have the possibility to test it directly on an hardware that is essentially very spreadly available, and in that way we start testing. And so the first day, I think we have the Windows IoT available. We decide so we can build something that can move, can explore, can. First of all, I'm thinking about a project like a sumo robot that can combat one behind the other. But in the first version, we don't develop it because we have other implication, other technology implication. So I don't know if I answer your question.
Yeah, from what I understood, it has been a long learning from changing. Am I
Oh
on?
yeah,
From
yes.
changing from the regular Windows development environment to this. But yeah, it looks very interesting, and I think it's also an inspiration for other Windows developers that would like to start playing with Internet of Things.
Oh yeah, absolutely. And also there's I missed to say another thing, that this version is also free, and it takes the possibility to many other developers to try it. You don't have to buy any license whatsoever. Let me say just another thing, that all our project is on GitHub. All the project of the rover and the other sample we develop, and after I share the link for this project, and we also accept many other person that want to participate. That is interesting for us. Thank you.
Awesome. Yes, please send me the link for GitHub, and at the end I'm gonna post everything on the event, and also on the YouTube page. I'll post all the links. Anybody else has any questions? I didn't see if we have any questions on the Q&A. You were mute, Max.
No, I didn't say anything.
Oh, okay, I thought. Okay, well, thank you for now, Marco. Let's, if we see any other questions, we redirect. Now, Markus.
Yeah.
Hello. Can you tell us
Sulamita.
a little bit about yourself?
Yeah, sure. So, I went to university to study electrical engineering. So I do have a bit of engineering background. Nevertheless, I've been in the public relations team working for Intel for about, I guess, 15 years now. So I'm totally out of this world, and basically when I worked on my project, which was kind of funny, I had to look up stuff on Google, like, programming in C, C++, it all had to come back, but it's kind of funny how easy it does actually come back. So after a while, I had to do less searching, and I could actually be more productive in coding for my system.
Cool.
Yes, and I heard, I know that your project is very typical of Munich. So can you tell us a bit about it?
Well, I actually thought I could keep that as a secret, but it seems I have to reveal it now. It's basically a system that allows you to brew beer at home. It's a home brewing system. And, I've always sort of wanted to look into this, but, when I saw what Intel Edison was capable of doing, then I thought, well, now eventually I have to get on it. I have to build a system, and I want to, pretty much automate as much as I can. And that's where Intel Edison comes in, and that's where Intel Edison helps me. So I'm actually sitting in front of my system. Let me just flip my camera over real quick. So there you see what I call my brewing tablet. That's that, because I control everything from a tablet, and it has the user interface currently running on it, as you see. Here is the controller box. So it's a chassis where all these things are inside. I got to work on the power supply a little. That's a little too big. It's basically a PC power supply. Here we have a solid-state relay board with 8 solid-state relays. These are controlling things as we go. And here, of course, is the rock star of my system. It is the Intel Edison board on the Arduino breakout board. Here we're looking at the brewing vessel, so that's the mash tun along with the stirrer. That is basically an old car wiper motor. Inside, you see that's the stirrer. Gas bottle, of course, we need a lot of gas in brewing. And here's another kettle. I actually got to step back a little bit. And this is the boil kettle, so here we are boiling the beer once we are closer to finishing the process. Now, you know, there are a few things in brewing that you need to do, and this is both at the professional level as well as at the homebrew level. And these things are basically, you know, starting from mashing in, so putting the grains into the water, making a mash, then separating the extracted sugars from that mash, which is called lautering, sparging. And, you know, in all of these, Edison is basically helping me, assisting me. It is, you know, writing a protocol so that I can later look into my protocol, into my brew day protocol, and see, you know, what has gone wrong, where were the temperatures, maybe I need to improve anything or stuff like that. After the separation, we then go into the boil, and after the boil, we need to cool the beer, and then we need to ferment it. And that's also, you know, for those who are maybe not so familiar with brewing, fermentation is super important for the beer making process. Actually, if you don't have your fermentation right, then your beer will not taste right either. And that's also, by the way, where Edison comes in. I have a separate control box, which I could probably show you as well. It's over here on my chest freezer. And this control box, you see 3 temperature sensors attached to it. One is basically inside that chest freezer. And, well, actually 2 are inside. One is in the beer, one is in the just in the chest freezer, and another one is lying on the floor, which detects the outside temperature. And with this control box, with this other control box, I'm basically making sure that the fermentation temperature is always right at any given point in time. And that also logs the temperature, and what it's producing is I hope you can see that okay here, is a chart over time. So there, the orange color is the beer temperature, and there at the end you can see I've risen the temperature. That's called a diacetyl rest, so you got to do that to make sure it doesn't have any off flavors and stuff. But you know, over basically 3 weeks, the temperature is nailed to the 10 degrees, which is very difficult to achieve actually for a home brewer, but Edison makes it possible. In that way, you know, we get not only good tasting beer, but we get also all the documentation, all the protocols, all these charts, you know, that I can then later on use to look up what has happened at which time and why may the beer not taste as it should. But, you know, as this chart showed you, this beer should taste right. Okay, good. So you've seen the system. I explained a couple of things for brewing too, so why don't we look at how the system works. Now I'm switching to the world-facing camera again here, turn on my brewing tablet, and on here basically I have all kinds of functions where I can go through the process, through the brewing process. At this point it only talks German, but I have actually you know, designed the system so that I could port it to English or any other language at some point as well. Now, let's look at one feature I was going to demonstrate to you. It's a very straightforward feature. Basically, what we have is the wiper motor from the car, and that drives the stirrer, and it does it just by hitting this button here. If I hit that, you see that a relay basically turns red back here, and the relay essentially switches on my stirrer, which is running now. Cool. And I can, of course, turn it back off by just pressing the button again. And that's a very basic feature, as I said, but you know, I can turn it on and off on my tablet, meaning I don't have to stand next to it. I can do something else. I can sanitize my beer hoses or whatever I need during the brew day. You know, basically Edison helps me to be, you know, flexible in where I am in my brew day here. And you know, of course the system itself, the software itself, can turn on and off the stirrer as well as needed. What it does too is it turns on and off a pump. The pump is basically back there It's just sitting here in my garage. I'm not using it today because I'm not brewing today. It is Wednesday afternoon, and you need pretty much a whole day to brew. So I'm just showing you a very basic setup here today. But anyway, so between the stir and the pump, these are two basic things that Edison controls. But what it does too is it turns on my two burners. So here you see that one pot is on one burner, and then over here we have another one. And what it allows me to do is to basically walk through the temperatures very, very precisely. And during brew day, you have to hold certain temperatures in the process, and you have to hold them accurately and make sure that they don't overshoot and so on. So what it does is basically here I have a temperature sensor. That is a one-wire temperature sensor. They're also called DS18B20, and they are normally on a brew day. They would be stuck in here in those thermo wells. Thermo wells are in here. You can see those here. That is one. And so I have two pieces in here. I'm measuring the temperature very precisely, and that's something that Edison does for me. And because Edison knows the temperature of my liquids, it can basically turn the burners on and off as needed. And how it does it? It basically switches the SSR. That's the SSR back here. And through that, it then turns on a gas burner controller box, which I built. That's back here. This is basically using standard technology that you would find in any gas heating of a household. So this is the controller box. All it needs is to be powered on, and when it's powered on, it turns on the ignition. It turns on the magnet valve. Here is a magnet valve for my gas. And it also makes sure that there is always a flame, because if there is no flame and the magnet valve is on, then you're basically poisoning yourself with gas, and that shouldn't be. So what I'm going to show you now is we are going into the mashing program. So I'm hitting mash here. So it shows me all the details about the mash, including the water volumes. And by the way, I haven't said that, but all this data comes from a recipe file, which is based on the beer XML standard. So if you go out there on the internet, you will find, I want to say, thousands and thousands of beer recipes based on beer XML. And my system just reads the XML file and then interprets what's in the file, so basically the recipe. And as you see here, I don't know if you can see that okay, I think you can. The mash-in step just is 25 degrees. I'm cheating here. I modified the recipe. 25 is way too low. But I did this so that I can give you a live demo. So 25 is something I can warm up with my hands. So I'm basically going to touch this one, and therefore it will think it reached the 25 degrees. So let me basically say so this is the data check. Let me just say data is okay, and what happens is after I say okay, it will go into the mashing program and it will start the ignition, and about 10 seconds after that it will turn on the gas. Let's see. So maybe you can hear the noise. That's the burner. And soon you will see a flame as well, hopefully. There it is. So basically, my system...
That's a dangerous live demo.
So basically, my system is now heating up the mash because it thinks it is below 25 degrees. And if you look then, here we have a current temperature, I don't know if that's okay to be seen here, of 20. So that's what this sensor is basically reading. Now, if I touch this sensor, then the temperature here will rise, and the system will know now I reached the temperature, I can safely turn off the burners. So let's see what happens. What I do is I'll show you this too. So here is the flame, here is the sensor. I'm going to touch this, which means I'm going to warm the sensor now. And let's see what happens. Now it turns off the burners because it sees that the temperature is reached. And through this, basically, I can go through the whole brew day without having to pay attention for my mash or for my boil all the time, because Edison does it for me. And again, while you move through all these temperature rests and temperature steps, it does it very accurately, and at the same time, it again writes a CSV file for me, which I then can look into later in Excel or your preferred spreadsheet calculation software, and I can see, how did the mash go, how did the boil go, and all these things.
And how did the last brew went? It tasted well?
Excuse me?
The last brewing that you did using this system, did everything end up well? Did it taste well?
Of course, Sulamita. How dare you ask? No, just kidding. But anyway, I don't know. Are we out of time or should we look into another feature here, because maybe that's a fun one too.
Let's move to the next one. Thank you for all this, and then we can come back. I'd like to just show everybody again a little view of all the projects, and then we can go back.
Perfect. Good.
Thank you, Markus. Then now we're going to the Netherlands to talk with Tim. Hi, Tim. Can we say a little bit about yourself?
Yeah, well, I'm a student in media technology. Actually, I'm studying in Rotterdam. And yeah, well, I'm really loving to build stuff. And like, for example, when I wake up, my curtains automatically open. So that's like one project. And my alarm goes off. And yeah, this was another project. I made it for school, actually. The assignment was to build some with the laser cutter and the 3D printer. So to mix that. So I based my design on the Pixar lamp from, yeah, well, you all know it. And yeah. So the head and the base is 3D printed, and then the frame is laser cutted. It's actually a laser cutted robot arm. Yeah, well, mixed with the 3D printed like Pixar design. So.
But your first version was already with Edison.
It's with Edison.
So you started with Edison already on this project.
Yeah. Well, like I came in touch with Edison on the IKEA hackathon, and that's also where I met Max. And yeah, well, the first project we built there was like an overview of the building, and then we added temperature sensors and sound sensors, and we would show like a noise map and a heat map on the building.
That was pretty cool.
Yeah. And well,
really like. I was there where the noisy zones. That was really nice.
Yeah. And well, that's actually where I first used the Edison, and then I got one, and I used it for my school project. So that's how I made this.
Can we and what the Edison does with the lamp?
Yeah, I used a framework, Johnny 5. It's like a Node.js, and it's a robotics framework. So there are 7 servos in the lamp, which I can all like control. So I can do fun stuff with it. For example, I can give my lamp a high five. Yeah, if it works. Okay, high five. Yeah. And well, you can also ask the lamp questions. Just make it a yes or no question. It's like, are you a lamp? Oh, or what's your question?
Is it sunny today there?
No.
No. That's awesome.
Or yeah, it is. Like so, one other thing I did was trying to recreate the Pixar animation, like when it jumps on the eye. I don't know if you guys recall it. Like it jumps a few times, but I cannot let it jump, so I skipped that part. And then when it jumps on the eye and it looks to you, that's like what I made. I hope you can see it good enough. It's like, so it's whoa. And that's when it looks at you. So.
Ah, cool.
Yeah, I'll do it again. Like it's like, hey, are you there? No, and then. So.
That is really cool. So you say you did it with Node.js framework.
Yeah, on the Edison.
On the Edison.
With,
where is the Edison?
Oh, it's right here.
Oh, okay.
As you can see it, like.
Yeah.
Some. I'll just talk about a few things I ran into when I built it. So actually, the first version was was built with the Edison, and then what I struggled with were the PWM inputs, because I use 7 servos, and the Intel Edison only has 5 PWM pins. So well, that was a bit of a problem because I had more servos. So what I did then was created my own PWM function that didn't really work quite well. You know, PWM is like what you send to the servo, so it knows what position it has to go to. And to fix that, eventually, that was like after my school project, I bought a shield which sends the PWM. That's like the one over here. I can't really show it. But that's the only extra thing, well, and the servos that I used.
You have a page on Instructables about this.
Yeah.
Yeah. I'll also add the link afterwards.
What servos did you use for that? Like, they seem pretty accurate. So, are they stepper or servo?
They are servos.
Oh, cool.
Yeah. Also, they are like the more expensive servos, because I first used the China ones, and for a few euros, and well, they all failed to keep it like it needs power to stand like this. So I also use the springs, but the springs are not enough to make it stand up.
Yeah.
Especially
okay, so
in the higher
hold it and the servos move it. So okay. Cool.
Yeah, I can also move it like by hand if I have a few controls, so I can, for example, control the upper arm. Oh, and then like I can. But I think I can turn the head, or like this. Whoa. maybe. I think you guys hear the servos when it moves really loud. Yeah, so I won't do it. Yeah, it does make a lot of noise. That's maybe. But yeah, this is my project.
That's very cool. I can do myself back. Why am I echoing? Marco, I forgot to ask you. You spoke about porting Windows applications, but is that on what, .NET, or what sort of language or framework did you use?
It actually is UWP, so Universal Windows Platform, developed in C#. Is essentially the same application that you can write for a Windows Store application for Windows Phone, for HoloLens, for Xbox. That's it. Exactly the same application.
Cool. And Markus, which language or framework did you use?
So first of all, I used Arduino only, but I ran into stability issues with the Wi-Fi library. I wasn't quite happy with its stability. So I basically switched after, I think, a couple of people, maybe Max included, influencing me to switch to Node.js, at least parts of it.
Just slightly.
So initially I had the web server part. I had that in Arduino, a self-coded web server using the Arduino Wi-Fi library, or Wi-Fi server library. And then finally, I let Arduino C++ only do the sort of intelligent part, and UI, all the web serving. I used a Node.js process for that, and I gotta say it's much more stable now, and I'm really happy with the stability that it shows now. I think you're on mute. Yeah.
Yeah, no, I was just thinking of some. Yeah, and so for all of you, because we have quite diverse technologies here being used: Python, Node.js, Windows. How important was for you? Those were the main languages or main frameworks that you were used to, or you decided to go because it was one of the supported languages, and how important that was for you? Anyone?
I can start. Can you hear me now?
Yeah.
Okay. I just wanted to get started as fast as I can, and I didn't want to need to compile anything, and I wanted to run parts of my code on the fly, and I was also used to it, so I just picked up Python. And I think it's the beautiful thing about Edison, because on other similar platforms like Arduino or Raspberry, you don't have that much power like in Edison. So you practically have to write in a low-level language like C or C++, but Edison has all the juice I need, so I just decided to use it.
Yeah, and then I guess me, I basically started with Arduino because it looked very, straightforward, I want to say. So the IDE wasn't overwhelming me. Plus, it let me code in C++, which is what I learned at university back then. I was scared like hell of JavaScript, to be honest, and that's why I didn't initially pick up Node.js. But when I basically familiarized myself and tried a couple of projects on JavaScript, I found out it's actually less scary than I thought, and so eventually that's how I switched to Node.js. But definitely for me it was the main reason to get started on our Arduino was because that was close enough to what I was familiar with already.
That's also for me. I use C# because it's the is one of the main reason I go to this technology, because I can continue to use all the tools and the language and all the APIs that I usually use for my home day work.
Yeah, also for me, like I'm a front-end developer, so I'm really familiar with JavaScript, and that's why I chose Node.js. I also prefer it over the Arduino language because it's just easier to read, in my opinion. But yeah, that's personal preference.
And I'm glad
So,
that everybody
I would
got.
also be interested.
Sorry, there is a delay on my video, Max. Go ahead.
I just wanted to ask, like, what's your favorite way of deploying the code and compiling it, or executing it in case of scripting languages, because like a lot of hackathons I went, and there is this XDK thing, there's this Eclipse plugin, and there's the way of just copying it with SSH, and I wonder like what other people prefer to do.
Yeah, well, I don't think it's the best way, but I use SFTP. So yeah, like SSH, that I just connect to the Edison via my favorite FTP program, and then I edit the files inside of the FTP program. So I'm like editing right on the device.
Yeah, I'm doing the same, so thumbs up.
So in my case, there's a different solution, because during the development, I can deploy directly from Visual Studio, and having to debug directly on the board. And when the application is done, I can deploy on the board, assessing it using a sort of a little web server that the board exposed, and I can reach it and deploy also the package from remote, also from geographically distributing the application. That's it's very easy in that case.
Yeah, I've been using the old school SSH method for this project because the code wasn't that big at all. So I've also been using the Edison for development as well. So I just use my computer screen and keyboard, and everything else is on Edison. But if I were doing something bigger, then I would automate it like using Jenkins or another similar solution.
Okay. Yes. So I can only say there's also you all say SSH and S copying it over. I think you can also, when you do over FTP, so SFTP, you can also mount the file system of the Edison, or mount with the Edison a local file system on your host system, and work on that with your favorite editor, so you don't need to copy over each time. Just keep using it, and it's syncing automatically over the network. So network-based file system, basically. So maybe Markus, what's your favorite way of deploying the code?
I didn't hear a name, but I guess since I was the only one who didn't say, you're asking me. So my favorite way, to be perfectly honest, is just using a USB connection, because I just hit transfer code and it transfers it over, and then once I'm happy with the stability of the code, do a bit of debugging. Once I'm happy with it, I'm actually using WinSCP. That's just, I think, another SSH-based Windows client, which lets you, access the Edison file system directly, and that's how, then I would put the recipe file onto my system, That's how I open and copy the log files that my system produces. What else was I going to say? Oh yeah, and sure, how I start the code then once it's on the machine is I'm using system CTL, because I hate it when I have to connect a PC on brew day to get my system started. So I'm using system CTL to basically auto start the sketch as well as the Node.js server when I turn on the system.
Well, we're on the top of the hour, and it was very cool. It's very interesting. I really like how different every project is. You know, from music to robots to beer and all the inspiration that you guys have. I'm gonna post all the links. I don't know if Markus, do you have any public link for your system or for your code, or if this is an encouragement for you to post it online?
Yeah, actually, you know, along the way, I came across a problem which I didn't mention yet, and that is that the DS18B20 temperature sensors actually work or did not work with Intel Edison. So it usually uses one pin, that's why it's called one wire. For Edison, it needs 2 pins, so I had to rewrite that library. And actually, I've already posted on communities.intel.com that I have that library, that Arduino library. So that's one maybe, you know, I'd like to share more. But of course, I was using other libraries for that too. So I would need to talk to these library owners first if they were happy with me to post the modified one.
Okay. We will keep one eye on that, and I'll post the projects from Ali, from Marco, and from Tim. And thanks everybody for joining. And yeah.
Maybe, Sulamita, we open a Google group or something like that where we can also post the whole thing and connect the whole thing, so we get, if Markus gets his library online and he gets the permission, he can post the information there, so everybody can interested join the group and get updates on that, or on future similar calls like this, or on the project progress of everybody.
Yes, right. We would like to make this more time. So if there is anybody in the audience that would have a project that would like to join us next time, just let us know. And follow Max on the Google group. And yeah, I'm not sure how to do that, Max. We can talk later and you tell me. And
I think we'll figure out.
Yeah. Okay.
Cool.
Well, if anybody has anything else to say, otherwise I think we're done for today. Well, thank you, and see you next time.
Thank you. Thanks.
Ciao.
Bye.
Bye.
Bye bye. Ciao. Ciao a tutti.